Hello and welcome to Algebra 2, Chapter 3.3, and today we're going to discuss graphing and solving systems of linear inequalities. So a system of linear inequalities is just two or more inequalities that have the same two variables, so just like our systems of linear equations. So remember though, with an inequality you shade, and so your solution is any ordered pair that works in both. That's still true, but it's going to be in this overlapping shaded region. Okay, so the graph is the overlapping shaded region. You're actually going to graph both, and then you're going to shade darker where they overlap. And so to graph it, you're going to graph it just like you graphed a one linear inequality. That includes graphing the line, what type of line, whether it's dashed or solid, and then doing your shading. So let's do a few examples. But first of all, remember you probably want to put the equations into slope-intercept form. Or you're welcome to use your intercepts, and you can change it to equals because it's going to be the same line. So negative 2y equals negative x plus 3 divided by negative 2. So we get y equals a positive 1/2 x minus 3/2. Okay, so to graph that, we're going to start at negative 1.5. And we're going to go up 1 over 2. Remember to stay in that same spot, up 1 over 2. Or you can go down 1, back 2. Okay. And this is going to be a solid line, so we're just going to go ahead and draw in our line. And we want to shade. And you want to do all this right now while you're working on this one. So our shading, if we pick a test point like 0, 0, if you plug that in, you're going to get 0s less than or equal to 3, which is true. So I'm going to shade everything above that line. So there's one inequality completely graphed. Our other one then is already in slope-intercept form. So we're going to start at negative 4. And our slope goes up 3 and over 1. Okay. This line is dashed because it's not equal to. Okay, need a test point. I can still do 0, 0. That would give me 0s greater than negative 4, which is true. So you're going to shade the entire side of that line. Okay, in pencil this works nicely. You can shade really lightly. Okay, so then what you're going to do, let me change my color here, is you are going to come in and you are going to shade darker where the two overlap. So let's see here, there we go. So right in here we are going to shade darker. So this is our answer region. Now, and you obviously wouldn't want to shade it that dark that you couldn't see anything, but you get the picture. What this means is that any ordered pair in this purple region is going to be an answer. So this ordered pair, this ordered pair, this ordered pair. Every ordered pair in this region works in both inequalities. So this is my solution. My solution is this whole purple region here. Okay? Let's look at another one. And on these you can have multiple inequalities. Okay? So starting with x is less than or equal to 0. The line x equals 0 is actually the y-axis. So there is that line. And if I want to shade less than or equal to 0, I'm going to shade on the left. Those are the x's less than 0. Then for y equals 0, well, that's actually the x-axis. There's y equals 0. And I'm going to shade above that because that's where y is greater than 0. And then the last line, I'm going to have to do a little bit of rearranging here. Negative y equals negative x minus 2, divided by negative 1, y equals x plus 2. So we're going to start at 2, go up 1 over 1, or down 1, back 1. And this one is also solid. And we can pick 0, 0 as our test point. If we plug in 0, 0, 0 is greater than or equal to negative 2. That's true, so we're going to shade on the side with 0, 0. And what we get is our overlapping region is right here. It's this triangle. So that means all the ordered pairs in that triangle are solutions. So definitely make sure you remember, always shade that overlapping region darker, and all you're doing is putting multiple linear inequalities on the same coordinate plane. So we'll finish in class. Let me know if you have any questions, and have a great day.